Okay.
Cool. Alright. Just write down.
我买个支架。我会买个轮胎，再买个GoPro。考虑。这个时候我觉得可以让索尼的40，索尼的40里面还有那个相机的支架，还有那个翻板，还有那个话筒，就配置特别好，价格也不是很贵，就非常的划算，实用性很好，性价比也很高，所以说我推荐你去买索尼40。恰饭。能比大藏王。
Cool. I've got a set of equations there for you. What's different to normal?
There's an extra
variable floating around, right?
There's 3 pieces of information.
Right.
3 variables, 3 pieces of information.
Right, I've got 3 equations,
Yeah.
right? So I have 3 pieces of information that relate 3 variables. Okay? Should I be able to work this out?
Yes. Yes.
Yes, right. So long as you have at least as much information as variables, say for a couple of little special cases, which we will go through, you should be able to work with it. Okay, great. Does anyone know exactly what they're going to do straight away?
Yeah.
Not really.
Okay. If the answer is yes, have a crack. If the answer is no, we'll work through it. Okay. Typically, if you only had just 2, yeah.
Can I use matrices to solve this? Did it have a 3?
Yes. Short answer.
3 by 2.
Well, hang on. Let me rephrase that. Can it be done? Yes. Can you do it? I don't know. Do you know how to invert a 3 by 3 matrix?
No. Oh no, fair point.
So there's your answer.
Forgot about that.
You can do it. It's not overly difficult, but it's the bigger your matrix gets, the more pain it becomes to invert.
Yeah.
So you can do it, but don't do it manually in methods. You do it later in uni stuff if you need to. But cool. Right. If we only had 2 equations, right, and 2 variables, what would we do to solve it?
You made both equal the same variable.
Make them equal the same variable.
So you
Okay, right. Substitution or
Eliminate.
elimination, right? You're going to substitute or eliminate accordingly, right? Usually, what's the very first thing that you do?
I'll rearrange the equations to make the variable the subject.
Make the coefficient the same.
You're thinking math. Go one step before that. Go planning.
Find out which
Number the...
Right. Give them names or numbers so that you don't get lost later when you go, hang on, which line was this referring to and whatever, right?
Yeah.
Is this mathematically necessary? No. Is it human necessary? No. Is it human very good idea because you're human and you make a dumb error? Yeah, very good idea. And it also helps later when you're trying to diagnose what went wrong. Right, if it ever stuffs up. Okay, cool. So we've got that. Great. What would you like to do mathematically from here?
Make
Your call. Anyone's call.
variable a subject.
You could. Waste of time.
You could
elimination.
eliminate.
Right, eliminate something, right? What would you like to eliminate?
1.3.
X, right? Because everything's got an X lining up for you, almost as though I've set this up as a nice easy example. Okay, which equation would you like to use first? Or equations would you like to use first? 1 and
3.
3? Okay, why did you pick 1 and 3?
It's easy. Nah. Yeah, it's easy.
It's easy? Okay, why is 1 and 3 easy?
Yeah, because it's only have x and y there.
Okay. Okay, so we're going to use equation 1 and equation 3. What do you want to do, add or minus?
Minus. Wait, add.
Add, alright. Why do you want to add them?
Because we only left just 2x, I think.
Right, if I add them, I'll end up with 2x, this and this cancel, this and this cancel, this and this. 2. Well, that makes it pretty easy. X is 1. Now, most of the time, you won't get such a nice easy set, right? But trying to save you some time. Out of curiosity, for the number of people that did try to do this by themselves, did you jump straight to trying to combine 1 and 2? Or did you use 1 and 3? Yep, good. That's an intelligent move. What I'm going to do, I'm going to do this way, and then we'll start with 1 and 2 for the sake of it, just to show you how much slower it is and why you want to pick an intelligent pair wherever you can. Anyway, cool. So we've got x equals 1. Great. What would you do now? Sub x equals 1 into what? All of them? Okay.
No, because would it even work with 2?
Okay. If I sub that in, right, say they're all 1s now. Well, now what are you going to do?
Make. Now you only have 2 variables.
Keep using 1, 3.
Okay. You can always sub this in later, right? If it doesn't immediately have an obvious benefit, don't worry about it. Okay, great. So we use the pair 1 and 3. Usually, what would you do if you only had 2 equations and 2 variables?
Find the next variable.
Okay, you need to find the next variable, right? Normally, you would just sub it in and get that free, but in this case, we've got more information floating around. Well, we use the pair 1 and 3. We haven't used 2 at all yet. So maybe we should use 2 with something. Okay. Well, we could use 2 with 1 or 2 with 3. I'm going to choose 1 and 2, just because. In this case, I'm going to say equation 2 minus equation 1. Okay, x minus x. Actually, no, I don't want to do that because I don't want to get rid of the x. Sorry. I want to do. We do a couple things. I'm going to do equation 2 minus 2 lots of equation 1. Okay, this minus 2 lots of that gives me negative x. This minus 2 lots of that kills off the y's. This minus 2 lots of that, single z. This minus 2 lots of that, 2. Okay, well we already know what x is. So,
Sure, right.
equals 3. Great. Okay, we've got 2 down, 1 to go. What would you like to do at this point? Right, sub what into what?
Just 3.
Right, sub these guys into...
Right.
I'm going to suggest that you do 1, but you could do 3. I'd probably avoid 2. Right, why would you pick... Why are 1 and 3 pretty obviously better than 2? Right, just because 1s, and here you've got more numbers. That's it. You are welcome to do whichever one you want though. Right, I'm going to recommend this, because humans are good with adding, and for some reason, just stupid with minusing. So sub everything into 1. So we get 1 plus y plus 3 equals 6. Cool. Therefore, y must be 2. Great. Cool. Alright. So therefore, our 3-coordinate system goes 1, 2, 3. Almost as obviously that I made that up with that in mind. Okay. Now.
Are we going to graph this and sketch it?
3D graphics is painful.
Yeah.
And it's not in methods, strictly.
So,
I've got the point 1, 2, 3 in a 3-dimensional system. How confident are we that that's the correct result?
Pretty confident.
Why?
Because there's no negative in any.
Say that again.
Because we can substitute variables.
Okay, right. So we shouldn't be confident without at least checking it quickly, particularly with multi-equation systems, as in more than 2. You should always, even with 2, you should always chuck it in and make sure it still makes sense. So 1, 2, 3. All right, 1 plus 2 plus 3 is 6. Yes. 1 plus 2 lots of 2 plus 3 lots of 3.
Yes.
Yep. 1 minus 2 minus 3. Yes, so we're okay. Only after you check it should you be okay. Having said that, 1, 2, 3 looks suspiciously right, so that's okay, so we're done. Alright, let's deliberately do this a dumb way, just so that when you do the results, you suspect something's going on. We'll put it, and we'll just put it here. Alright. 1, actually we'll do 2 minus 1. Cool. So we're just going to restart, and rather than looking for an intelligent thing where I can knock out 2 in one go, I'm just going to knock out 1 and 2 just because I'm acting as a stupid. Okay, well these two are minus, then I get y plus 2z equals 8. Did I do that right?
Yeah.
Yep. Cool, great. Well, that doesn't go anywhere. Well, I've used 1 and 2, so I have to use 3 with something now. Well, I'll use 2 and 3 because that seems like a reasonable thing to do. 2 minus 3. Get rid of x. 2 minus 3 gives me 3y. Which way am I going? 2 minus this gives me 4z. This minus this gives me 18. Cool. Great. What can you do from there?
And make y the subject.
The one way.
Yeah, you can make y the subject for that.
Yeah, so you can do y equals 8 minus 2z and you can
So it's in
substitute
your
2.
Right. Alternately, if you don't like substitution, if you prefer elimination, you could times this whole thing by 2 and then eliminate. You've got options. But point being, this is back in the old school, like just simultaneous equations, like year 9, 10, sort of more year 10 sort of stuff. Cool. At this point anyway, it should be auto part sort of stuff, right? So say this guy is the same as saying y equals 8 minus 2z. Stuff that in. So now I've got 3 lots of 8 minus 2z plus 4z equals 18. 24 minus 6z plus 40, plus 4z equals 18. We've got minus 2z equals negative 6, therefore z equals 3. Okay, so last time we had 2 very short lines, this time we've got 1, 2, 3, 4, 5, 6, 7 lines before we even get to our first thing. Once you've got 1, everything else will fall apart, because this you can put back in. So we'll sub this back into, call it restart. What do we get? 6, 2. Y plus 2 lots of 3 equals 8. Therefore, y equals 2. And then you can sub into whichever one you want. 1 seems like most obvious thing. X plus 2 plus 3 equals 6. Therefore, x equals 1. Therefore, 1, 2, 3. So you still get to the same conclusion, unsurprisingly, because it's math. But 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, so by picking an intelligent first move, you can save yourself a bit of time. And certainly the numbers here are a lot easier than some of the numbers up here. Obviously, the bigger the numbers get, the more negatives you have, the more likely you are to be human and make some dumb error. Cool, so that's that. I want to type this on a CAS so that you guys know how to do it. If you are in exam 2 and you get a 3 system, usually you're better off using your CAS. You can get them in exam 1, but they don't tend to turn up that often, unless they're trivial like this. So, it doesn't matter if you're in Scratchpad or if you're in, I forget what the other thing's called now. The calculator sheet. So you can either be in the Scratchpad calculate or you can be in the calculator sheet, either. So just have an empty page or just go to a new one, it doesn't really matter. Cool. What we're going to do, don't bother typing any of those yet. Go to menu, then algebra, I should probably write this up. Menu. What one's on? 3. Algebra. Number that is number 7, solve system. And then it'll give you an option. You'll always deal with linear, but it doesn't matter for you guys. You can pick 1 or 2. It doesn't really matter. Solve system. Wait, what is that actually called? 3, 7. Yeah, solve system. Solve system again. Cool. Okay, from there, you're putting in your data. How many equations do we have?
3.
3. So turn that into a 3. When you press, now, if you press up and down from that, it's going to try and change the number. So you actually need to hit enter. Sorry, not enter, tab.
You said that after.
括号
It doesn't matter.
这个
If you press enter,
三
it'll
个
auto
这是
fill
两
the
三
rest
方
of it
程，
anyway,
这是三
correct?
个方程，在这儿之后，这是选的那个数量3，然后确定把数打进去，然后逗号 x y z，然后搜。这个逗号怎么打？
Yeah.
逗号。
So everyone's got
这是
like
你是
that
在第二
box that's asking you how many variables
全部
and
推
what
过
the
去，
variables
推
are.
全
Yeah.
部推过去就打。
Cool.
哦。
If you want to change line, hit tab. If you hit enter, it will automatically just go, oh, okay, take all that information and go. So you want to hit tab to go down the successive things. You want to change it so that you have 3 different variables. You can change the variable names if you like. It defaults to X, Y, Z. And then I think it defaults after that to W. It starts going backwards through the alphabet and that. But you can change them to whatever you want if you want them to be something specific for some reason. Cool. So hopefully at this point everyone's got, it'll go back to the original page, it'll have solve, a massive open bracket, 3 empty boxes, and then comma in curly brackets, X, Y, Z, and then close all bracket. Yep. Cool. Guess what you're about to do? Right, fill in those 3 blanks with? No, not just a variable. The equation, right? Equation 1, equation 2, equation 3, into each of those boxes. Ready, set, go.
Yeah.
操！也是个啊，
What is the times?
病的啊！
Get rid of the times then. Oh, it'll have 2 times y and 3 times z, and you get a line. Yeah, because you've got 2y and 3z.
Oh, no, it's 3 times negative y times negative z equals negative 4.
What? Okay, I'm down. I know what you've done.
Go. 我重新看了一遍第5部，豆豆啊，然后呢，发现就上午已经重看了3遍了。我发现中文能力好，被削的好惨。对，是确定我也是，我也不止啊。我想出来操作比别人多。很正常。
Finish that back out, 1, 2, 3. Yes, good. That's how
我也这么觉得。
Make sure still forgets up something.
他打那一段，他把自己牙齿变成水母，对吧？对。那个人把全部头发变成蛇，那不就是猪肚上？
对啊，我也这么认为。
我操，他的冒泡是最糟的。嗯。这泡泡才会散是最糟的。这个叫哪个泡泡？对啊，它还会散，真的就跟糖尿病人一
Several
样。
typos are all done. Okay.
真的跟糖尿病人一样。
Now, particularly from Kinshuk's perspective, he's definitely learned a very specific lesson. How trustworthy is the CAS when you're typing this out?
Not very,
Why?
because it's a smart double.
What are you worried about happening? Typos, right? If you make a typo, it will still just power on through, right? You have to double and triple check what you have typed in. Whenever you do anything with the CAS, double and triple check that you've typed in what you meant to type in, because the CAS will sometimes go, oh, you typed this, but clearly you meant this, right? And then it'll just run it. So you have to be 100% that what you told it to do worked. What you told it to do was what you wanted it to do. Okay, cool. So it spits out great. Would you say for this particular example, was it faster to do it on CAS or by hand? It's probably faster to do it by hand, right? Because the amount of time it takes you to set up the equation, right, and double check for all your typos and all the rest of it, it's probably actually faster to do this by hand, particularly if you do it the intelligent way. However, we're going to make an adjustment now. We're going to make this.
这样每天9点睡觉，9点半睡。什么？要9点半之前睡觉。你知道我前天昨天凌晨9点半不是早上吗？可以。前天就是睡觉到8点，11点睡觉。现在虽然他要7点钟，只睡8个小时，小时10了。这样会把疲劳和压力留到第二天的。
Yep. Okay. So, before you even hit enter or type this in, taking a look at that, Adam's already said it. What's a bit sus?
There's two bits of the same information.
Right, these two things. Are they any different?
No.
No, right, they're just multiples of each other. Okay, how many pieces of information do I effectively have? Only 2, because I've just repeated myself here. So if I've only got 2 pieces of information and 3 variables, what should happen? Okay, it not work. That's a vague statement.
You made me sound very capable.
It's going to be much more difficult.
It's going to be
Much more difficult.
much more difficult. Not quite, it's actually easier, it's just less helpful. Okay, so go back a dimension, right? Imagine if we just had x and y,
Yeah.
right? We've got x, let's say x plus y equals 3,
Okay.
and 2x plus 2y equals 6.
Yeah.
We've got 2 of the same equation,
Okay.
right? Has infinite solutions, right? Why?
Because they're the same line.
They're the same line, and essentially I'm asking when does this line intersect with itself? Well, everywhere on the line. Now, take that one step again. So I'm intersecting with that line. Does that mean that every possible point is a solution?
No.
No. What does it mean? I have infinitely many solutions, but not every possible point is a solution.
2 points in the ending answer will be the same.
No. So, I had one line there and another line on top of it, right? I have infinitely many solutions along this line,
Yes.
but I can pick random points that are not part of that solution space. Okay. I want to take that idea and go to this. Don't freak out. Okay. So, in this, I have a 3-dimensional space, right? But I've got what's called 1 degree of freedom, right? I've got this extra variable floating around that I can't nail down to a fixed point. So I end up with this line moving through 3-dimensional space in some way. It might still be in an XY plane, but it's more likely to be somewhere on an angle, somewhere in the 3-dimensional plane. So I've still got infinitely many points that are that are solutions to that. However, I also have infinitely many points that miss. Right? It's just gone up a dimension. That's it. Okay? Cool. Do we want to do this manually? We'll do it manually first. Okay. We'll see what we can do. Right, if we join 1 and 2, we know we're going nowhere fast. So we'll join 1 and 3, since we know that actually gives us something. Oops. So 1 plus 3, which is the same as before. 2x equals 2, therefore x equals 1. Okay, great. After that, what have we got? Therefore, y plus z equals 5 from that, and minus 1. Negative 1, negative z equals negative 5. Yeah, it's the same story. Okay. So, I've taken that result, put it into the first, and taken that result, put it into the second, and just shuffled the ones across. Okay? What do you notice? Right, they're the same rule. Yeah? rewrite this, we could rewrite it as negative z plus 5. Yeah? Think of that as x for a second. What's this describing? Right, just straight line, right?
Yeah.
Okay, if we define x as that way, y is that way, and z is this way, which way is this line going?
Towards us.
Towards you.
Down.
Okay, towards you is in...
This way. Sorry, if x is this way and y is this way and z is this way.
No, we're going to into the page, yeah.
Because that's negative.
Okay. Does this line vary with x at all?
Yeah.
X is always 1.
Okay, no.
Okay, so going this way, x is always 1. So that line has to always be when x is 1. So x is 1 this way, but since we also have a z-axis, x is 1 this way. So I have to be on this sheet. Okay? And then I follow this rule. So as z increases, y will decrease because of that negative. Right? And we have a y-intercept of 5. Okay? Great. So we're somewhere on this sheet. The y value is going to be 5 up there, and we're going to be coming down the page that way. Well, it depends which way I define the c being positive, but it's either going this way or that way. Point being, we've ended up with a straight line through 3D space. Yeah? Beautiful. Is this immediate? Sorry.
We have a pole.
Yeah, you have a pole basically going through an infinitely thin line, but infinitely thin pole, but yeah. Great, that's fine. Was it obvious looking at that? Well, maybe it was in this case since they were perfect multiples to begin with. So, okay. It will not always be so obvious. Sometimes you'll end up with combinations where it's you have to fiddle your way through, and eventually you'll realise, oh, when I replace one value that I know, I don't know the other two because they always have the same rule. Right. And it's possible that you get even more complicated things because you can get a line that goes diagonally across everything, so it's moving in x, y, and z. So you won't get this nice 2 thing, you'll end up with the same thing with x, y, and z all at the same time, which can be annoying. So we have to know what that result looks like when you type it, so type those into the CAS. Right? It's very similar to the last one, so just go up, copy it, and then alter it. Yep.
Does the CAS have the ability to graph these?
Don't think so. I don't think it does 3D plots.
I don't even know how you would draw a 3D plot.
No, it's not
If
hard.
you just draw a line, it's not that bad, but when you want to draw other things, it becomes problematic because you have to choose where your viewpoint starts. And then you have to choose what angle you're looking on and all the rest of it. So usually you'll do it in a PC because then you can just spin it around and move it so it can adjust all those, whereas this, I don't think, it just doesn't have the graphics capability for it, I don't think. Not sure, I'm gonna try. There's probably someone that's written a program for it, but I don't think there is on default. It's not really big methods anyway, so we have to worry about it.
I like
Yep. Good. If you get C1s, that's good.
Oh, my What the what? Okay.
两个逃
I
课
see problem. I see interesting thing.
Oh.
你不打了吗？
I got x equals 1, not x equals c1 plus negative.
Unless I type mine.
这不是废话。
x1, y equals negative c1 minus 5. Or negative in then
Oh,
bracket.
sorry, no, I've done a different version. Sorry. I'm looking at the wrong thing. That was a different one I was making.
Okay.
Wait.
So,
Is it been 10?
no, I got an actual answer. What did I do wrong? Oh, that should be the two.
Oh. -4.
Two. There we go. So you get x equals 1, y equals negative, c for you guys will be 1 minus 5, and z equals c. Cool. Did we get that as an output?
Yes.
Yes. No one got anything else?
I don't know why. But
Cool. Yeah. Yeah. We'll discuss why in a second, but everyone definitely got that as an output.
Yeah.
Yep. Okay. So what's this telling us? Well, x equals 1. Great. We already knew that from before, so that's fine. What's this thing saying?
I don't know. Y equals z minus 5.
What's this quick hands?
This C1 or C2 or C3, it'll be in bold, by the way. It's always in bold. What does C stand for in y equals mx plus c? Constant. Right, well, yeah, it's interpreted as a y-intercept, but the C itself stands for constant. This is constant number 1. Okay, what I'll get you to do, just because we can, just hit enter again to make it redo that exact same thing.
So, which equation do
And then hopefully it'll spit out C2 this time. Everything else will be the same,
Oh.
it'll spit out C2.
I thought it was just scrolling my thing on the page. It says C5 now.
Okay, fine. Cool, so everyone got the same thing, just has C2s instead of C1s, yeah?
Yeah.
Right. All it's doing is telling you, you can pick whatever number you want for that, like potentially. Right, whatever number you pick for this, y will equal negative, well, the negative of that minus 5.
And x will always equal 1.
X always equals 1, regardless of what you pick for this.
Therefore, it doesn't really need to be 3 then.
If we rearrange, if we look at this, right, to expand that bracket, oh, this says that, whatever z is, the negative of that, and then add 5. So it's just a different way of representing